Okay, welcome again to this tutorial. Best Science Brain YouTube. We are still on combustion of hydrocarbons, estimation by a formula of hydrocarbon by combustion, quantitative analysis. We are already giving out 2 videos on this empirical and molecular formula and estimation of formula compound by method of combustion analysis. So on the whiteboard we have what is known as residual gas. So volume of residual gas. We're going to abbreviate this with VREG, volume of residual gas. So let's consider this reaction between methane and oxygen. So when methane or when hydrocarbon bonds not going to give you CO2 and water are the only product. Then let's assume that 100 cm³ of methane was introduced into the reaction container. 100 cm³ of methane was introduced into the reaction container. That is VI means initial volume or the volume that was introduced. Then an 80 cm³ of oxygen gas was also introduced simultaneously. So the VI for oxygen is 80 cm³. You note a must that the whole volume must be used up. During the reaction, out of the 100 cm³ of methane introduced, 100 cm³ also of methane reacted, because that VI means reacting volume of gas. VI is the volume introduced, VR is the volume that is reacting. So we introduced 100 of methane and 100 of methane also reacted. Methane was exhausted. Then we introduced 80 of oxygen to react with methane, and then out of the 80, 60 was used from the 80. Question is, maybe somebody may ask you which of the two gases is said to be in essence. So you don't say it's going to be methane, how that we again they're going to be methane because 100 is more than 80. No, it is not methane because you're seeing 180. No, you have to compare the volume introduced and the volume that reacted for each gas. 100 was introduced for methane and 100 reacted. That means at the end of the day, methane will be exhausted and no methane remaining in the container again. Then we introduced 80 of oxygen and 60 reacted. At the end of the day, you're going to have oxygen remaining in the container. Oxygen remaining in the container. As how many cm³ also remain? 80 minus 20, that you now have 20 cm³ of oxygen remaining or left in the container at the end of the reaction. That means oxygen gas is the gas in excess, but the volume introduced is more than what we react. Why methane is called the limiting gas. Now, what is residual gas? Residual gas is the gas remaining in the container at the end of the reaction, and that includes the volume of the unreacted gas, in this case 20 cm³ of oxygen, plus the volume of the gaseous products. GP means gaseous products. The products are carbon dioxide and steam, water vapor. So when you add the product, one of the products, gaseous products, plus the volume of the unreacted, remaining the excess, the surplus was there 20, that gives the residual gas. Let's assume that at the end of the reaction mixture was cooled. Cooled means you allow the steam to condense. But when you condense steam, it turns to water. So if the reaction mixture is cooled, that means this steam will no longer be a gas. We'll remove it. So if the reaction mixture is cooled, the residual gas now becomes only the unreacted gas volume plus carbon dioxide, because steam is no longer a gas when it is cooled. So when you have a question like this, you have to understand the meaning of the word residual gas before you go to calculations. Okay, on the board we have a question there that says 15 cm³ of gaseous alkane was exploded with 120 cm³ of oxygen. So volume of the alkane, against hydrocarbons, we can represent alkane using CSHY. We don't know the name of the alkane, so we can use this formula to represent alkane. Is 15 cm³. Was exploded with 120 of oxygen. So volume of oxygen is 120 cm³. So having done that, after cooling, 90 cm³ of the gas remained. So after cooling, after the reaction, what remains after the reaction what's called residual gas. So volume of residual gas, we can call it 90 cm³. And remember, residual gas include the product and the excess gas. Then after assumption with excess potassium hydroxide, 45 cm³ residual gas, residual oxygen was left over. Before we go ahead, We have to define residual gas by formula. Residual gas, as I said, is volume of unreacted gas plus the gaseous product. The product here is CO2 and also steam, water. But we will not include water because cooling will condense the water to liquid. So we have this residual gas, 90 cm cube is obtained by adding the volume of the unreacted gas and CO2. So which of the gases is in excess here? If you read the question, you have a clue. The gas that is in excess is oxygen. They say after absorption with potassium hydroxide, which gas is absorbed by an alkali? The gas that is absorbed by an alkali, be it KOH or NOH, is carbon 4 oxide. So the gas that has been absorbed, when the mixture was passed into alkali, CO2 was absorbed. And then what remains is 45 cm cube of oxygen. So the unreacted oxygen gas is 45. So based on this formula, residual gas is 90. Volume of unreacted oxygen gas is 45 cm cube. The volume of CO2 that was produced, can get it by making it a subject. So volume of CO2 becomes 90 minus 45, giving us 45 cm cube. So that is the CO2. That the gas absorbed by the potassium hydroxide alkaline solution. So this is volume of CO2 produced. Then what is the volume of oxygen gas that reacted? 120 was used in the reaction, but from the question we see that oxygen gas was in excess. So what volume reacted? So volume of oxygen that reacted, you have to get it. The whole 120 did not react. 120 was in the reaction, 120 was introduced, but from the question they said that 45 cm cube of oxygen was left over. So subtract 120 from 45 so that we can know the volume of oxygen that participated in the reaction. When we subtract, we're going to have 75 cm cube of oxygen that took part in the reaction. So we have to get the volume of the hydrocarbon in the used in the reaction, volume of CO2 that was given out. We ignore steam because the solution, the mixture was cooled, so steam is not part of the gas again. It's not a liquid. So oxygen will now become 120 minus 45, taking away 45 of the oxygen gas was left unreacted. So the volume of oxygen gas that reacted will now be 45, taken away from 120, giving us 75 cm cube. Having obtained this, what is the next thing to do? What we'll now do is write the equation, the combustion equation for hydrocarbons, which I introduced earlier on in the previous video. CSHY plus S plus Y over 4 oxygen, giving us SCO2 plus Y over 2 water. Having written that, what then do we do? This is within CNQ based on the equation. Hydrocarbon. Then one of the oxygen that reacted, we got it in at 75 cm3. The volume of CO2 produced is 45 from our analysis earlier on. Having this, then you find the ratio of these values. You can divide all of them by 15 so you can go through. That will give us 1:5:3. Then equating coefficients. S here is equivalent to 3, so S is 3. Then S plus Y